Okay, in this short video we're going to do a convolution, and this is based on what we did in class today. In class we had a system and its impulse response was e to the minus t times a step function, so a decaying exponential that starts at 1 and decays off starting at time 0. And our input that we looked at real briefly was a signal that basically a shifted rect function. So it has a value of 1 between 0 and 2. And we want to know what the output is. And so to do that, we can find the convolution of x of t and h of t, the impulse response. And as we'll show, that we can reverse the order and it's the same thing. We're going to use that. So for calculating this, I'm going to have h of tau, and so there's my decaying exponential, e to the minus tau u of tau, and this is what we're going to flip and shift over. So the input starts at it has a value of 1 between t minus 2 and t. So we take that function, we flip it, and now we're shifting it around. So the first, as I've drawn here, we see that the product of this function and that function is 0 when t is less than 0. So y of t equals 0 when t is less than 0. So there's our sort of first thing we know about the output. We can then increase the value of t, and so the next time is when t is greater than 0, but t minus 2 is not greater than 0. So t minus 2 is less than 0 and t is greater than 0, so t is between 0 and 2. In this case we have y of t equal to well, a function, and this is 1 and this is e to the minus tau, right? So e to the minus tau times 1 is e to the minus tau d tau. And the limits on our integration, we just need to integrate between 0 and t, right? Because otherwise the product of those two is 0. So we just need to integrate from 0 to t, and we end up with 1 minus e to the minus t. Okay, and our second, or I guess third here, time that we're interested in, the last one, is when now t minus 2 is greater than 0. And so in this case, we have t minus 2 greater than 0, so t is greater than 2. Y of t is equal to, again, 1 times e to the minus tau d tau, and the limits of integration now are from t minus 2 to t, because otherwise the product is 0, so we don't need to worry about that. And if we do that integral, we end up with this function. So we can write this in piecewise form here. Y of t is 0 for t less than 0. It's 1 minus e to the minus t for t between 0 and 2, and it's minus e to the minus t plus e to the minus t minus 2 for t greater than 2. And that's equal to what we found in class. If you remember in class, we said, well, if we know the output for an input of a step, then we can find the output for a step that's also shifted and multiplied by minus 1, because it's a linear time invariant system. So we add the output for the step, and then the output when we multiply that by minus 1 and shift it, and we just add them together, and that's the output when the input is this function. And so in that case, if we want to rewrite this, we would say 1 minus e to the minus t times u of t, but then we have to turn this function off at u of t minus 2. And then the next piece here is turned on at time 2. And if we do the math here, we see right that these pieces are going to cancel, and we're left with, so this is the response to a step function, and then we have that response to the step function but shifted over by 2 seconds. So we have a t minus 2 there and a t minus 2 there. And then of course we said we have to multiply by -1. So this is the answer, but this is the equivalent way of saying the same thing.